Hey everybody, welcome to Math with ACE. We are in Statistics with ACE today. We're going to be dealing with continuous probability functions, specifically the uniform distribution. And a uniform distribution is one where each outcome is equally likely. And what that looks like is you have a distribution that is flat across the top. And we use function notation on the y-axis to represent that function value. So we'll call it f of x. And then our values of start and finish, we would label underneath on the x-axis. Now, f of x is another way of saying y. It's just saying f is a function of x. It's telling us it's a function. So y and f of x are a lot of times interchangeable. Sometimes y is not a function, so we have to be careful there. But this is telling us we have a function. It's a function of x, so whatever we put in for x impacts the function. Now, just like with our discrete distributions, when everything added to a whole, the area in this region is one whole that we're talking about. So this value, the area under the curve between the function and the x-axis, that is equal to 1 or 100% if you're dealing in percents. Now that's going to help us as we work to calculate probabilities because we know that the probabilities need to be between 0 and 1 inclusive. But how do we label a distribution with the information that's given? Where can we go with this? So let's look at the problem that we're considering here. We have a function where f of x is 1 over 20, and the values go from 0 to 20. Those values from 0 to 20 are specific because the function value is 1 over 20. So I want you to think about this for a minute. If the area under the curve is equal to 1, then the product of the base and the height also need to equal 1. Why? This is a rectangle, and the area of a rectangle is equal to base times height. You can call it length times width, but either one, they're interchangeable. But what that's saying is this base value here times this height value here has to be equal to 1 whole. So the height of the function, whenever we're labeling function notation, remember we're saying that the function is a flat line here. That function value is 1 over 20. So 1 over 20 goes at the top of that bar where the horizontal bar is and hits the y-axis. You would label the function value there. That means that from 0 to 1 over 20 is the height. And the distance there is 1 over 20 minus 0. It's just the function value. So the distance from 0 to the function value is the function value. Just think, if you're at 10, the height is 10. If you're at 1 over 20th, the height is 1 over 20th. So we have a height of 1 over 20th, 1 over 20. And the base goes from 0 to 20. So that distance, that length, or that base is 20 long. If I multiply 20 times 1 over 20, remember fractions, whole numbers are always over 1. You multiply straight across. You can simplify before you multiply if you want. But 20 times 1 is 20. 1 times 20 is 20. And 20 divided by 20 is 1 whole. So it is by design that the uniform distributions have the inverse. The height and the base need to have inverses of each other, reciprocals essentially, so that they can multiply to be 1. Okay, so if I had 1 over 5 as my height, then I need my base to be 5 in order for this to be a valid uniform distribution, because 1 over 5 times 5 gives me 1. So when I'm trying to figure out how long the base is or how high the function is, it all needs to multiply to 1. So you want to keep that in mind, and you can use your equation solving skills to get there. All right, now let's solve some probabilities. Going back to this distribution, I'm going to move the 1 over 20 right next to it. And we had 0 to 20. We want to find the probability that x is between 0 and 2. So I'm no longer dealing with the entire probability uniform distribution. I'm dealing with a portion. And let's say that this is 10, this would be 5, then this would be 2. And so I want to know the probability of being in this region. So I'm calculating the portion of that region. How much is that? So again, that is a rectangle, but the base here is 2 and the height is still 1 over 20. So I would find the probability that x is between 0 and 2. I would take the base of 2 times the height of 1 over 20. And if you want to turn that into a decimal, that's fine. 2 over 1, I'm going to get 2 over 20. Or if you simplified, that's 1 over 10 or 0.1 as a decimal. 1 over 20 is the same thing as 0.05 if you're dividing it out. So the probability of being between 0 and 2, since it's 20 long, is 10%. That's 10% of the data. So think about this, 10, 20, 30, 40, 50, 60. I would multiply that 10 times to get to 20, and 2 times 10 is 20. So that's a tenth. What about between 4 and 5? I'm sorry, 4 and 15. So 4 is here. 15 is here. That's a much larger region. How large? Well, let's calculate. The probability of being between 4 and 15 is equal to the base. Well, how far is it from 4 to 15? In order to find how far, that's a distance, which calculates with the difference, which is subtraction. So 15 minus 4 is 11. So that distance is 11. So 11 times 1 over 20, which is the height still, height isn't changing, gives me 11 over 20. Or if I wanted it as a decimal, I could say 0.055. So about 55%. So that chunk is about 55%, which means everything else is 45. What about 2.3 to 12.7? Now, I'm not going to be able to accurately just graph this out. 2.3, I would say, maybe it's right about here. And 12.7, maybe that's right about here. So the green area is here, and delete the blue for you. But I have the skills in order to calculate this. I just need to know how far it is from 2.3 to 12.7. So what I do is I find their difference. So 12.7 and 2.3, if I do 12.7 minus 2.3, I get 10.4. So that base is 10.4. So the probability that x is between 2.3 and 12.7 is equal to the base distance of 10.4 times the height still of 1 over 20. Now I'm combining decimals and fractions, not the most friendly. So in this, I'm going to turn that 1 over 20 into the decimal of 0.05. So 10.4 times 0.05 gives me 0.52. That's about 52%. So one thing you should note is whenever you're doing these calculations, your values should always be between 0 and 1 because we're talking about probabilities. We don't have negative probabilities and we don't have more than a whole. We can't be bigger than that rectangular box. Okay, so I'm going to do a little erasing to get my colors. And I want to know the probability that x is exactly 15. Okay, so I'm at 15 right here. So my base, what is the distance from 15 and itself? I don't have any distance. I'm at 15. So 15 minus itself is 0. I have no width. And multiplying that by 1 over 20 means the probability is 0. You cannot be equal to an exact value in a continuous distribution. You have to be equal to a range. Now, if I wanted to find the average, You can calculate the average and the standard deviation. I'm going to talk about the average, but if I wanted to find the average, what would I would expect? If everything is equally likely between 0 and 20, I would expect to be right in the middle. Well, how do I find right in the middle? I average these two. In order to find the average of these two, I do it just like I would normally calculate the average between two things. I would add 0 plus 20 and divide that by 2. So 0 plus 20 divided by 2 is 10. So I would expect the value, so the average here is 10. And there's a formula for it. To find the mean, if I was to call this A again and this B, the formula for the mean is you take A plus B and you divide it by 2. If you're wondering, the standard deviation is the square root of A minus B squared over 12. Okay. Thanks for watching. I hope this helps you with the uniform distribution.